The goal of this demo is to showcase the successful execution and detection of PFCP attacks against the communication between SMF and UPF within the 5G core. More specifically, this demo focuses on the execution of the PFCP session deletion attack executed by a compromised SMF against UPF. The PFCP session deletion attack and other PFCP-related attacks have been defined and implemented by Sancus in the context of the ACE component. On the other hand, an intrusion detection system, which is part of SID, has been deployed within UPF in order to detect potential PFCP-related attacks. Next, the security events generated by this intrusion detection system are sent to the SID dashboard. For this demo, Open5GS and EuroRansom are used, while the attacks have also been tested successfully in the Nokia testbed. Therefore, the key objectives of this demo are as follows. First, to demonstrate the PFCP session deletion attacks through ACE. Second, to detect them through SID. Finally, evaluation results and achievements of these activities within Sancus are presented. Starting with the execution of the attacks, first, we can see the Docker containers with their names that indicate the network functions within the 5G core. This is the configuration state of the container implementing the user equipment. The PDU session is correctly established, and the data network interface is up and running with an IP address of 10.4.5.0.6. Opening another terminal session with the UE instance, we observe that indeed, the network interfacing is online. We will try to ping a website located in the UE's data network using said outward-facing interface. The transmission of the ICMP packets is successful, indicating that the connection between the UE instance and the data network is correctly established. Next, the PFCP session deletion attack is executed. The attack script of ACE requires a source IP address, a destination IP address, and the network interface. After the execution of the attack, the ICMP connection between the UE and the data network is corrupted. This is because the UPF's PDU session context serving the given UE has been deleted. Opening up Wireshark shows that all PFCP packets are appropriately formatted, with all attributes and relevant fields being present. The SEID attribute of each packet is increment, with the goal of hitting the session of a UE instance. Upon revisiting the PDU configuration screen, we find that everything seems to be functioning as intended on the same interface. However, our attack targeting the N4 layer has compromised the interface's access to the data network, impacting the UPF's configuration but leaving all session states unaffected. Pinging the data network address again, even after stopping the malicious packet transmission, produces the same results because the attack's effects persist with SEID, making it more serious. The second objective is the detection of the PFCP attacks using an AI detector. The detection program receives as arguments the Docker image, the ID's executable, the Kafka topic on which the IDs will report, the address of the Kafka consumer, and finally, the directory where the network traffic files are stored. While the attack is executed in the background, the detector monitors the network traffic data of UPF, generating the corresponding network flow statistics and recognizing the malicious network flows as PFCP session deletion attacks. Next, the security events are sent to the appropriate Kafka topic. On the right side, we can monitor the security events that are sent successfully to the Kafka topic. Finally, the security events are successfully consumed by the Kafka topic and visualized by the SID dashboard. First, for the training of this detector, a 5G PFCP intrusion detection dataset was prepared and published by Sancus. This dataset is available in IEEE Dataport and Zenodo. According to the evaluation results, the detector can successfully detect the PFCP attacks. In particular, the F1 score of the detector reaches 85.4%. Based on these activities about modeling, implementing, and detecting PFCP attacks, various papers were published by Sancus in international scientific journals and conferences.